Hello and welcome. In this video, I'm going to introduce density, both of solids and liquids, and you can kind of think of it as applied, math, working with significant figures and rounding and units, okay? So we have density, which is a physical property. Here we have vegetable oil, which has a lower density than water, which has a density of 1.00 grams per milliliter. And we know that oil is less dense, so it floats on water. And the reason for that is twofold. Its solubility and also differences in density. All right? Now, density is a ratio of mass to volume. Density is, according to this formula, mass over volume. And we use small m to represent mass and large V to represent volume. All right? So let's talk about the units you normally have. Grams per cubic centimeter is for solids, and liquids is usually grams per milliliter because you're measuring them in some kind of thing like a graduated cylinder. Now, keep in mind that cc, it means cubic centimeter, cm cubed, which is cubic centimeters, right? And milliliter are actually all the same. All right, it's a quantity of volume that's the same. It does not imply a cube or anything like that, and this is true for solids, liquids, or gases, for example, okay? Now, what you need to do is first measure the mass of the object, and we always use a balance for that. There's no way around that. Now, for volume, it's possible to measure it directly, and that's if you have a rectangular object, okay, length times width times height, or you have a cylinder, for example, and you know it's pi r squared h, the height of the cylinder, or so on, okay? Now, if you don't have a defined object, it's really weird shaped like this lid here, then you're going to have to measure it indirectly, and I'll show you how that works in a bit. But once you have the mass, once you have the volume, you plug it into this formula and you get your density, okay, which is the ratio of mass per unit volume. So let's look at an example of a cubic wood block. Let's say it measures 0.80 centimeters on a side and it has a mass of 4.20 grams. So that's just one of those small blocks in this image. What is the density? All right. So of course you want to calculate the mass. You put it on a balance and you weigh it, and let's say it weighs 0.420 grams. All right. Now step 2, you want to calculate the volume. Now we know the volume formula for a cube is the length cubed, okay? And so if you look at this little figure here, the length and the height and the width are all 0.80 centimeters. So we can plug it into this formula and we get 0.512 cubic centimeters on our calculator. But remember, 0.80 has only 2 significant figures, so we want to round that off to 0.51 cubic centimeters. All right? The final step here is to calculate the density. Now that we know the mass is 0.420 grams and the volume is 0.51 cubic centimeters, we can plug it into this formula and we get a very long, lengthy display on your calculator, and you want to make sure to round that off to 2 significant figures. The reason being is that 0.51 has 2 sig figs, 0.420 has 3 sig figs, and remember, the loser wins. So we have 0.51 centimeters cubed, dictating that our density needs to also be 2 sig figs. So let me show you some examples here of how we calculate density, okay? As we've seen, when you have an object that's very well defined, you can just measure its dimensions and calculate the volume, and then of course use the balance to measure the mass. You need 2 things to calculate density: mass and volume. Mass is always obtained with the balance, and that's most straightforward. The volume involves a few tricks, okay? So this is a cylinder, and we want to measure the length of this guy here. It's 15.1 centimeters, 15.1 centimeters. I'll measure the diameter here. It measures 1.0 centimeters. And now, I'm not sure if you can see this very well in the video here, but we're going to go ahead and place this on the balance to get a mass. 28.88 grams, okay?
from those two information, we can calculate the density.
All right, so let's go ahead and do that. Here's a cylinder here represented in the figure, and we have some information that I've obtained in that little video demonstration, okay? We know that the length of the cylinder is 15.1 centimeters, okay? And we know that the diameter is 1.0 centimeters. Now the diameter is from one side of the circle all the way to the other. The radius is half of that, so the radius is 0.50 centimeters. Now the volume for a cylinder is pi r squared h. So you just plug these in, there's pi, the radius is 0.50 centimeters, that's squared, times 15.1 centimeters, okay? And so when you do this on your calculator, you get a rather lengthy display, but we want to round it off to 2 significant figures because our radius has 2 sig figs and the loser wins, okay? So the volume of this cylinder is 12 cubic centimeters. Next, what we want to do is, of course, calculate the density, okay? We know that the volume is 12 cubic centimeters, okay? And the mass, if you remember from that video demonstration, is 28.88 grams. So we know density is mass divided by volume. You plug those into your calculator and you get a very long, lengthy display. And we want to round this off to the fewer number of significant figures. In the bottom of this fraction, we have 12, which is 2 sig figs. So we want to round this off to 2.4. The units there don't cancel. Make sure they're in there. Grams per cubic centimeter. And this is a solid, so we use cubic centimeters for the volume unit in the denominator or bottom part of the fraction. Let me show you another video of another density measurement.
Now, what about this? This here is called tin. And these pieces of metal are very jagged. They don't have a well-defined geometry for which we can calculate the volume. So what do we do there? Well, we use the indirect measurement of a volume, okay? So first of all, I'll take a few of these, a handful, and I'll place them on the balance here to get a mass. Okay. All those chunks of tin cumulatively add up to 4.55 grams. Okay. Now we're going to take this graduated cylinder here, and we're going to place some water in here. Okay. It does not matter what volume we have as long as there's enough to submerge the metal. I'm going to lean down very carefully and measure the meniscus. And I get 13.5 milliliters, okay? Now I'm going to take all these bits of metal that I've weighed on the balance and place them in this graduated cylinder. When they're placed in this graduated cylinder, we should see the volume of this liquid rise up a little bit, okay? The difference in the two volumes are going to be the volume of the metal, okay? When we do this, we always want to kind of jiggle any air bubbles out of there to avoid any error readings, okay? And I'll lean down once again and we'll measure the volume. And I get 14.5 milliliters, all right? So from those two information, we can calculate the density of the tin metal.
All right, so ignore the title of this slide. This is actually density of tin metal, but and here are the little bits of metal in the figure here. So we've obtained very simply, once again, always on the balance, the mass of all these bits of metal. It was 4.55 grams, okay? Now, for the volume, we had to measure it indirectly by the rise in height of that liquid. We knew initially I had 13.5 milliliters of water, and after I added the bits of tin, the volume went up to 14.5 milliliters. So please do not divide any of these two numbers here. You need to calculate the change in volume, which is the volume of the metal, right? Because we put the metal in there and the volume went up by 1 milliliter, okay? Now look at this situation here. We got to watch out for significant figures. Each of these two volumes is accurate to the tenths place. So guess what? We need a number that has a tenths place. We just have the number 1 here. So very carefully make sure you write 1.0 milliliters when you do the math here to maintain the level of precision of our glassware that we're using, right? Okay, now that we have the volume, we can proceed to plug it into the density formula. So it's going to be 4.55 divided by 1, and we can see how the math is very easy there, and we get 4.55. But wait a minute, that is a mistake. First of all, we have the incorrect sig figs and no units, okay? 1.0 has 2 significant figures, so I need to round this 4.55 to 2 sig figs. We do that by writing down 4.6, and the units there are grams per milliliter. Now remember, tin is a metal. It's a solid object at room temperature. So normally metals and solids, right, we write the densities in grams per cubic centimeter. So we want to write 4.6 grams per cubic centimeter. Yes, we could write 4.6 grams per milliliter, but just the idea of milliliter implies liquid. So normally for solids, we write grams per cubic centimeter. Let me show you another density determination of liquids.
Now, what if you have a liquid? A liquid is very easily measured. Here I have water, so we know the density of water is 1, but let's test that fact, okay? So here I have a clean, dry, graduated cylinder, and it goes up to 10 here on the scale. So what you need to do is 0 the balance while that glassware is on the scale. Now it's reading 0, okay? And I can place any arbitrary amount of water in here as long as it's within the confines of the scale. So it's in between 6 and 7 here. And I'm gonna go ahead and put this on the balance, and it's reading 6.46 grams, okay? So I know the mass of the water. You can't just pour that onto the balance directly. All right, so we have 6.46 grams. And now I'm going to lean down and very carefully measure the volume. And it's reading 6.41 milliliters, okay? 6.41 milliliters and 6.46 grams. From those two data, we can calculate the density of this liquid. We could do that for gasoline, mineral oil, water, or whatever we like, okay? So those are the various ways that you can measure density.
All right. Once again, ignore the graphics on this slide, but the content here is completely correct. So we're going to measure the density or calculate the density of that water that was in that graduated cylinder and see what we get, okay? So recall again that we placed the water in a graduated cylinder and it increased in mass by 6.46 grams. So we know the mass is 6.46 grams. Very simple, okay? The volume was measured in the graduated cylinder by looking at the calibration marks on the graduated cylinder and just reading that off. And we got a volume of 6.41 milliliters. So the mass is easy to measure. The volume is easy to measure here with liquids. And of course, we use the density formula. Please memorize this at this point in the course. And the density is 6.46 grams divided by 6.41 milliliters. And we get a very long number on our display of our calculator, okay? Now, each of these numbers has 3 sig figs, so we want to round the final density off to 3 significant figures, which gives us 1.01 grams per milliliter. The density of water, as you know, should be 1, but this is real life. This is an experiment. Thanks for watching. Please like, give a thumbs up for my video, and please consider subscribing to help my channel grow. Have a great day, everybody.